Okay, so today's class, I think so far, just to recollect what we covered so far. So Databricks, we introduced Databricks and what is DB utils, Databricks utilities, which includes file operations, notebook operations, and widgets, which are nothing but some kind of parameters, which will help us to perform the Databricks activities interactively. And then we looked at the various kinds of files that we can read and write. And yesterday we looked at how to write the data and how to perform different functions like display, count, all those common data frame methods, and also some SQL operations, right? So after that, so yesterday I think, I don't know how many of you remember, like I was telling that unless we perform an action, the data may not be compiled, sorry, executed. So if you declare a data frame and unless you try to get the data using display function or count function, something like that, unless you write a code and execute, which will show some results, the code will not be executed. It will get compiled. If there are any compilation errors, it will show. Otherwise, it will only compile, it will not execute. So that is the concept called as lazy evaluation or lazy execution. So what do you mean by lazy evaluation or lazy execution is, unless you write an action in the sense you want to see something from the data, unless you want to write a code which will help you to see something as a result, that is called an action. Like example, if you declare a data frame, that will not give you anything, right? You will not see anything. In this case, in this example also, okay, yeah, cluster is already running. I don't know. Okay, I forgot to turn off the cluster. Okay, that's fine. Yeah. So if you see this particular command, so all the commands above, yeah, let me run the classroom setup because that is a pre-setup to get the files. Yeah, if you see this command, so command number 5 here, what we are trying to do is we are giving a schema and we are providing a path. Using that, we are trying to read the data. So at the end of the day, if you run all three commands, that is nothing but the cell together. What I can say is, we are not trying to see anything. We are just trying to provide a reference saying that, okay, I want to read the data inside this for source path, and we are trying to give the schema so that we can see the data accordingly. So we are not trying to see anything. We are just declared the data frame. That's it. So there is nothing that we are trying to see as a result. It's just a data frame reference. So this is called transformation. This is not an action. But in case if you want to see the data that is there, then that is called an action. So unless you perform an action, right, like display is a preliminary action. Unless you perform an action, all the code that was earlier compiled will not get executed. Only when you run the display command, then all these commands will be executed. That means the code that was compiled, right, that will be sent by the driver to the worker nodes, and they will execute based on the number of workers that were running on the cluster. The load will be shared, and then the final results will be given back to the driver node, and driver will display the results, right? So also, like if you perform count, it's not only display. Let's say you are performing count, right? Counts df dot count. See here, if you run it, here you are performing something. You are trying to get the count, and the count will be displayed. So unless you write a code which will give you some results, right? So that is called action. But if you're writing something which will not give you anything, let us say, for example, I wrote something like this: select, let us say I'm taking only one column. So name is one of the column, right? and this is df2, let us say. So this code will not be executed. Okay, so this code will be compiled, like if the data frame exists or not and this column exists or not. Those preliminary checks will be done. Unless I try to display the data inside it, it will not tell you if there are any runtime errors or not, right? So that is called lazy evaluation. So we need to be very careful, because earlier we used to get one question with a sample example saying like, this is what a developer is trying to do. Is this code getting executed, or is it code will not execute? So likewise they will give some questions. Okay, so here is the example that you can see. Okay, so this is the theory part, obviously, especially purely in the exam point of view. But having this knowledge will help the people to answer at least one question with respect to the database. Okay, so going to the next one, data frame class. Okay, column class. So this is also again another theoretical part. So far we know what is a table and what is a data frame. So it's all like table kind of structure. But what Databricks is trying to say is, always you don't need to declare a complete table. If you want to declare a column, they will also accept that. So a column can be declared and a column can be used like it just like a regular class. So, okay. So I mean, for the convenience, I am going with Python only. So here you can see you can declare a column, and here by using just column col, we have declared a column. So what is the difference between the data frame and this column structure is, data frame will contain bunch of columns like a table structure, but column will only accept only one particular column, and you can have a number of rows. That's the idea behind it. So using this also we can perform some operations, right? So I mean, most of the times we never used it, but there is such concept which will allow you to store the data in a one single column, right? So that is all about that. I don't want to focus much on this, but column will allow you to perform all the operations. Just in case if you want to find out, you can execute this notebook. This notebook will execute without any issues. But nothing much to worry about this particular piece. This is not a high thing that you need to worry about. Okay. So what else? Yeah. So I think on last two classes I was telling like, okay, we can perform some date conversion operations, some time conversion operations, right? I think I already shown you in the previous classes. So for example, if you have a column and you have to transform that within the given structure, right? So you can do that using the timestamp operations. One thing is two timestamp that we have seen in the earlier class. In this class, the notebook has Unix timestamp. I don't know how many of you are aware, like some systems will go with Unix timestamp. For example, Teradata. I'm not sure about Informatica. In my experience, Teradata by default gives the Unix timestamps, and JDE also gives the Unix time. I mean, it will have a different timestamp, right? So our goal is to convert those things into the regular timestamp, right? So Unix timestamp means it starts with 1970 January 1st. So it won't start with earlier years. That relative timestamp will be given as an integer. Okay. And if you ask SQL Server, it starts with 1900 right? So just in case if someone is trying to migrate those systems which supports unique timestamp while saving the data in the local database, so we need to definitely take that value and convert into the regular Gregorian calendar, right? So that is where this function can be used. So the point that we need to understand here is, we have the datetime conversion functions just like any other programming language. We can apply at the column level. We cannot apply a single value. We can apply at the entire column level, just in case if the source system is giving us some Unix timestamps, integer values, or some string which is not a standard timestamp conversion, then yes, by calling those functions and by passing the date format, we can definitely achieve what we are looking for. Okay, So here in this case, you can see they are converting the column which is like a Unix timestamp by default. Let us execute. Maybe that will give you more idea. So let me run all the above because it's all about the classroom setup to get the data. And the next thing is, let me take the parameters parquet file path and we read the data. Okay, somewhere yeah. Okay, so this command, whatever you see, he said like put the partitions as 8. So what will happen is, even if you have spin up a cluster which has 20 worker nodes or 10 worker nodes or 100 worker nodes, no matter how many worker nodes you have set up, it was telling that keep the partitions 8 means split the entire work into 8 equal executions. That means 8 equal jobs. That way what will happen? The data will be split across 8 files. So let us say you are providing 1 gig file to cluster, and when you convert that into Parquet, you will see 8 partition files created in the target location, the location where you are asking it to create. So likewise, when you read the data also, if you have 8 files or 64 files, automatically it will be merged into 8 partitions. That's the idea behind it. So it will be used for optimization in case if the data load process is running a lot of delay because of the execution, then we will set up this property to a higher value like 16 or 64. Of course, it depends on the number of workers and the number of cores, that is primary, but by default we use it for the optimization. This will help us to share the workload by the executors. If you give it as 16, then the entire work will be uh, split into 16 parts. And while reading the huge file or writing a huge data into the backend storage, it will perform the 16 partition files. That is the idea. I mean, not just Parquet file or anything. Even when you write the CSV file also, it will create a 16 partitions. Of course, you should have a huge data. If you have 1 MB file, it won't split into 8 partitions. It will maybe writing it to 1 or 2. But if you have lot of data, let's say 10 gig files size of data, then it will try to write all the data into 8 partitions. 8 equal, almost equal, near to equal partitions. Otherwise, this is not mandatory. This is only meant for the writing the optimization techniques. Okay, so now let us run this code. So here he is trying to write the Parquet file and he is trying to repartition it. So let us see what is there inside this. First of all, I would like to see what exactly is there inside it before I do something. Okay, so it has timestamp in this format, side request. So what he is trying to do here? Okay, has taken the column. Okay, here is the schema. Obviously, it's not a standard timestamp format. That's why it went with the string. But what he's trying to do, he is selecting the column timestamp and he's renaming it as captured it and the other columns. Okay, so I don't see any issue here. And okay, so he's renaming it. Okay, I understand. So he's telling us like either you can rename it like this by calling the select, or you can call it as a function with column renamed. I think we already tried this in the earlier class, right? And okay, finally this is the new data frame. Okay, so the next thing that, yes, here we go. This is what I'm trying to say. Okay, with column rename timestamp to capture it, and then select star comma Unix timestamp and then passing the value. So let us see what happens. Okay, so he is converting the regular timestamp to Unix timestamp. He is trying to do the other way. Okay, so let us see what happens after this conversion. So it was fail. So seems like he tried to do wrong operation for the wrong value. I think this function will not work. But in case if you want to convert, what you can do is to timestamp, and you can pass on the data format. So it is YYYY It's T is a string, right? That's why you need to put it in a single quote, and then HHMMSS. That's it. Now let's see. Okay, now it got converted. So it will give you, see, now since we provided the correct format, it has converted to timestamp, right? See here, the first column is a string, but the last column is a timestamp. So that is how we can use the timestamp functions. Of course, if it is a standard format, the value is in a standard format, we don't need to. But in this case, what happened is because of the T in between, it was unable to convert. So what I did is I said like, okay, it's a string, you ignore it and take the rest of the format. That's why we were able to get the results. Okay. And what else? Option 1, alias. Okay, he's trying to explain how to call alias and all. We can take the big ugly name explicitly, rename it. Okay, so this is all about renaming. Okay. Okay, so other functions include, if you want to extract only year, then you can directly write year, and also you can write month, or I think you can also write day as well. You can also write day of the month in case if you want. Not only this, so this will give you month. Okay, page preview. Oh, it is, yeah, this is the table. Okay, and let me display whatever they has written. Okay, he has converted it, and let us see what he has taken. So this is the function for year from the timestamp, and I believe this is the function for year, sorry, month. But in case if you want to get the day of the month, you can also do that. So how to do that? There is a function called day of month. It will give you the day, right? Okay, so here he has taken the combination, two columns together. Nice. Okay, show. Yeah, I don't know, I never covered it, right? So this is the Databricks has introduced the function called display to data frame, but originally Apache Spark Foundation team who invented the Spark framework, they come up with the concept of show. So show also displays the data, but Databricks has come up with a better function which will give you the results in a structured manner, like a tables and cells. Okay, that's the difference. But in a nutshell, show and display, they are not nothing but similar functions which will display the results. Okay, so overall, like, these are all the common programming methods and functions that we use in day-to-day life. So obviously, when it comes to timestamp, there are so many ways that people can send us the data. Our job will be day-to-day operations. We transform the string timestamp values into real date or timestamp values depending upon the format they send. Okay, so what else? Aggregate functions. I think this we covered some of the aggregate functions earlier as well. Yeah, group by. So group by is a typical function that we use on a day-to-day basis. But when you try to do group by, obviously you may try to get the all these functions, average, count, sum. That is the idea, right? When you group by, your goal is to get some aggregate results for based on the columns that we want to. So these are all the things that we can do. So in this case, what he's trying to do, he's trying to do group by, and he's trying to perform the sum operation. Okay, so let us see like what are the results he's trying to put. Again, partitions, the concept is same. He is providing the path and then he is declaring